Okay guys, so here we go with the video solutions for your practice test, okay? Going to start off with question 1. Hannah wants to rearrange all of her school textbooks on a shelf. She has a book for math, music, history, chemistry, and 3 different English texts. How many ways can they be arranged? Well, first of all, we need to know that there are 7 books, okay? We've got 1 for math, 1 for music, 1 for history, 1 for chemistry, and then another 3 for lit. So we have a total of 7 books. Well, the number of ways that we can arrange 7 objects we know is just equal to 7 factorial. So therefore, there are 7 factorial ways, or just 5,040 ways. All right. In a non-calc assessment, 7 factorial would probably be okay. However, it is just 7 times 6 times 5 times 4 times 3 times 2 times 1. And you should be at the level where you can do that in your head. In how many ways can they be arranged such that the math and music books are next to each other? Okay. So if we know that the math and music books have to be next to each other, what we do is we treat them like they are one single book. We don't treat them as 2, we treat them as 1. So instead of 7 objects, I now only have 6 that I can arrange. So I've got 6 different spots there that I'm able to put them. So this one here, that is math and music. And now it's just a simple matter of going 6 times 5 times 4 times 3 times 2 times 1. So what's 6 factorial? However, we can arrange math and music as either math first and then music, or music first and then math. It doesn't matter where they are, we just know they have to be together. So we also have to times it by 2 factorial. So we have to double our answer because it could be either way. 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360, 360 times 2 is 720, then we have to double that. That gets me to 1,440. And that would be how many ways there are to arrange them in that way. Now here for question 2. In year 10, a student has to pick 6 subjects out of a possible 17. How many course combinations are possible? Okay, well that is simply just 17C6. Again, in a non-calc assessment, we would expect just that answer, okay? Remember, it could also be written like that, but I like having that C there just so I know that I'm dealing with combinations, okay? And just for the sake of it, I've figured it out, and the answer is 12,376. But again, non-calc, we wouldn't expect you to know that, so 17C6. Actually, maybe we would. Disregard that. Okay, if one of the subjects is compulsory, how many course combinations are there? Well, if one of them is compulsory, that means we don't have a choice. We have to pick one subject from one subject. Well, I can write that as 1C1 because I have to pick it. How many do I have left over? How many do I have left over that I can choose from? Times 16C5. Realistically, you could have just written 16C5 and that would be your answer. However, I'm writing 1C1 to show the markers that I know what I'm talking about, that I'm doing 1C1 because I have to pick a compulsory subject. So I'm showing the marker, I understand the question, whereas if they see 16C5, they may not get that you understand the question and are just getting the numbers wrong. Again, non-calc assessment, that would be a fine answer, but I'm going to figure it out because I have some time. It's 4,368. For the next question. A 4-person track team is to be made from 7 people from Victoria and 5 people from Tasmania. Well, how many teams will have no Tasmanians? Well, if I have 5 of people I can choose from, if I'm not choosing from the Tasmanians, that's 5 choose 0. Well, how many ways can I do that? That's just going to equal 1. Okay? But now I also have to take into account all the people from Victoria. So my answer is going to be 7C5. And this is absolutely a question you can do without a calculator. It's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial, 2 factorial. Oh, sorry guys, it's not 5, it's 4. This should be 4. That changes this answer. And that's 4, that's 3. Well, the 4 factorial knocks out all that. The 3 factorial is actually equal to 6, so that gets rid of the 6 as well. So my answer for this question is there are 35. There are 35 ways in which we can do it. Okay, when doing these factorial notation type questions, always try and expand it out and show all the factors, because it's going to help you cancel out a lot and make these questions a lot easier than you may think they are. Well, how many teams have at least one Tasmanian? How many are going to have at least one Tasmanian? Well, we just found out that 35 have none. So 35 have no Tasmanians in the squad. Well, if 35 have no Tasmanians, that means all the rest of them have to have at least one. Okay, it's the complement of that event. So, to figure it out, how many people do I have in total? I have 12. 7 Victorians, 5 Tasmanians. So 12C4 would be if there were no restrictions. That'd be all the possible teams. Well, then I just have to take away 35 because that's the complement of my event. Again, this is a non-calc question. So let's see if we can figure it out without a calculator. 12C4 is equal to 12 factorial over 8 factorial, 4 factorial. I know my 8s are going to cancel out, so I'm going to rewrite this as 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. Well, 4 times 3, that's equal to 12. I can divide 10 by 2 to get me 5. So my final answer is going to be 11 times 5 times 9, which is 55 times 9, which is 495. So it is absolutely possible to do this without a calculator. Take away 35, because I have to take away the amount of teams that had no Tasmanians in them. So there are 460 different ways to do it. Expand a plus b to the power of 5. This is where we use our binomial expansion using combinations and Pascal's triangle. Okay? You know it's going to be in the form like this, okay? And just bear with me while I write all of this down. K2, A3, B2 plus B3 plus K4, AB4 plus K5B5. Okay, I will always start writing it just in that way, because after that you can substitute all the values in, but you just want that nice notation straight away so you know what you're working with. K0 is always going to be equal to 1, so that's just a to the power of 5. And remember now, the rest of them we can treat as combinations. So this is 5C1, A4B, plus 5C2, A3B2, plus 5c3 a2b3 plus 5c4 ab4 plus, and then k5 will always be equal to 1 as well. Your first and your last terms are always going to be equal to 1, so you don't have to worry about those ones. Well, now we have to figure out what each of these are, and it's actually quite easy to do without a calculator when you think of the formula. So a to the 5, that's easy enough. 5c1, well, anything choose 1 is just itself. So that's going to be 5. So we've got 5a4b. Remember, for our combinations, NCR equals n factorial over n take r factorial. Okay? So for for example, this one specific example, 5c2, well, that's 5 factorial over 3 factorial, 2 factorial. So it's going to be 5 times 4 divided by 2. That's going to be 10. You could have also figured out that line of Pascal's triangle and written it in that way. Both answers would get you here, but it really doesn't matter as long as you get the right expansion. Not a to the power of 4, it's b to the power of 4 plus b5. And then this would be your expansion for that one. Now the next question, find the sum of the first 5 coefficients of the expansion. Now attempt non-calc and check with a calculator. I did this without a calculator, so I'm really hoping you guys do this without a calculator as well. But let's just go about it. It's going to be the same exact form that we wrote the first one. So k0, a5 plus k1, a4b plus k2, a3, b2 plus k3, a2b3, k4, ab4 plus k5b5. Okay, now I'm going to do my coefficients. So I know it's a5 plus 5c1 a4b, 5c2 a3b2 plus 5c3 a2b3. And finish off with that b5 at the end. Now, we should note that we didn't have a and b in our expansion. We had 2x and we had 1. This is where we substitute in our values so that we can figure out the actual answer. I always like writing it in just general a and b to start off with, because after that, it's going to be much easier for us to just substitute the values in instead of trying to figure it all out at once. So now we've got just a to the 5, that's going to be easy, plus 5c1, and then that's going to be 2x to the 4. And since b is 1, we don't have to worry about that. B to any power is just 1, so we don't have to write that for the rest of the equation, essentially. Plus 5c2, 2x cubed, plus 5c3, 2x squared, plus 5c4 times 2x. I'm not going to write that last term. Why am I not going to write it? Because the question asks for the sum of the first 5 coefficients. Well, this is 1, 2, 3, 4, 5. We don't need that 6th one there. Now we have to try and figure out the coefficients of all of them. Luckily enough, the coefficient of that first one is just the number 1. So it's going to be 1. Okay, plus Well, what's my next one? 5c1 is 5. 2 to the power of 4. 2 times 2 is 4. 4 times 8. 4 times 2 is 16. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So that is 5 times 16. Plus 2 to the power of 3 is 8. So for this one is going to be 10 times 8. Then for my next one, 2 to the power of 2 is 4. 5c3 is going to be 10 again. So 10 times 4 plus 5 times 2. And 5 times 2 is just going to be 10. I don't think I need to write that one out, expand it like that. So now we're going to add all those coefficients together. So we got 1 plus 5 times 16 is 80. 10 times 8 is 80. 10 times 4 is 40. And then add that 10. You get a total of 242. So the sum of the first 5 coefficients is 242. All without a calculator, guys. This is the level of algebra you need to be at for this course. Okay, I'm not trying to freak you out, just trying to prepare you. Evaluate this in factorial notation. Well, 2 times 10 factorial over 6 factorial, 4 factorial. I'm going to knock off the 6 straight away. That's going to get me to 2 times 10 times 9 times 8 times 7. Now on the bottom, I'm going to write out 4 factorial. Because now I can cancel out a lot more of my factors. Okay? 4 times 2 is equal to 8. Get rid of that. 3 is 3 times 9. So my final answer is going to be the product of 2, 10, 3, and 7. 2 times 3 is 6. 7 times 6 is 42. 42 times 10, 420. And that'd be that answer. Again, no calculator. Express n times n take 1 times n take 2 over k times k take 1 in factorial notation. So we want to write this in terms of just factorials being multiplied together. Well, what if we started off with, for my numerator, I've got n times n take 1 times n take 2. Well, that is the start of n factorial. So I'm going to write n factorial here. On the bottom, k times k take 1. Well, that's the start of k factorial. So it's k factorial in the denominator. And then I'm going to write a fraction. Now, we know that we've taken something away from that n factorial. Remember how we cancel out factors? I'm going to know that there's some sort of variable here. I'm just going to call it b. I know that there's some sort of variable on the top as well, because k factorial doesn't go all the way down to k take k. So that's going to be a. This is where we need to try and figure out where we stopped. N take 1, n take 2. Well, next should be n take 3. Since it's not there, we know that we've taken out that factor. So for b is n take 3 factorial. Because we've gotten there, because we know we've taken that out. Same thing goes for a. That's going to be k take 2 factorial. Because those factors have cancelled out on the top and bottom as well. So my final answer, n factorial, k take 2 factorial, over k factorial, n take 3 factorial. That's cool. Solve the following equations. Just trying to solve some basic linear equations. All right, that 4 goes to the other side. We've got negative k over 3 equals 6. Negative 4 means plus 4, so you get 6. Times by 3, so negative k equals 18. Therefore, k equals negative 18. Easy enough. 2 outside of 2y plus 3 over 7 equals 1 take y over 2. Multiply this side by 2, multiply that side by 7. So that's going to get me to 2 times 2, 2y plus 3 equals 7 outside of 1 take y. So that's going to be 4, 2y plus 3 equals 7 take 7y. If I expand out this side of the bracket, 8y plus 12 equals 7 take 7y. Now I need to group my variables on one side, my constants on the other. That's going to help me solve the problem. 15y equals negative 5. So y is equal to negative 1 over 3. And that is my final answer for that one. Question 9, we're talking about gradients of lines and trying to find the equation. Okay, so my first line has a gradient of 2 and passes through the point 3, 5. So since it has a gradient of 2, we know that we can write it in the form y equals 2x plus c. Has to be like that. Well, now I just plug in my point. So let's plug in 3, 5 into my equation. It's going to get me that 5 is equal to 2 times 3 plus c. So 5 equals 6 plus c. And if 5 equals 6 plus c, then c is just equal to negative 1. Put that back into here. Y equals 2x take 1. And that's that equation there. Next up, line B. Same exact method. We know the gradient is equal to 3, so y is equal to 3x plus c. Substitute in my point 1, 2. Sorry, negative 1, 2. Negative 1, 2. So 2 equals 3 times negative 1 plus c. 2 equals negative 3 plus c. 5 equals c. Put that back into here. So this one has y equals 3x plus 5. Find the equation of the line that connects the y-intercept of A to the x-intercept of B. Well, we've been told that the equation of line A was y equals 2x take 1. So therefore, the y-intercept of A is just equal to the point 0, negative 1. That was easy enough to figure out just because we know the y-intercept from that gradient intercept form. Gives it to us straight away. The x-intercept of B. To find the x-intercept of B, we need to try and find the values in which y is equal to 0. The x-axis is where y is equal to 0. We need to find that point and then substitute it in. So, if y is equal to 3x plus 5, we need to say that 0 is equal to 3x plus 5. And then we're going to have to solve for x. 5 equals 3x, sorry, negative 5 equals 3x. And so x is equal to negative 5 over 3. So the coordinate of that point is negative 5 over 3, 0. Now we know the gradient of a line between 2 points equals y2 take y1 over x2 take x1. It's the change in y over the change in x. The change in y, negative 1 take 0. The change in x, 0 take negative 5 on 3, which equals negative 1 over negative 5 on 3. When we divide by a fraction, we flip the fraction and we multiply. So we're multiplying by the reciprocal of negative 5 over 3. So my final answer is 3 over 5. Okay. Therefore, my line has equation y equals 3 over 5 x plus c. Well, this is a line between 2 points. So if I want to try and find the value of c, I plug in one of those 2 points because I know that satisfies the equation of the line. I'm going to pick the point which has the x value of 0 and the y value of negative 1. Those values are much easier to work with. So putting in the point 0, negative 1 gets me negative 1 equals 3 over 5 times 0 plus c, and then negative 1 equals c. Therefore, my final equation is 3 over 5x take 1. Okay, I'm labeling my answer just by underlining them. You can also box your answer. Some people highlight them. I just like having a clear and distinct answer that someone can clearly go, okay, that's where. Sometimes your messing out gets a bit your working out gets a bit messy. Not your messing out gets a bit worky. Your working out gets a bit messy. So just be careful. You clearly show that you know what you're talking about and you've labeled your answer. So if a line has equation x plus 2y take 1 equals 0, find the equation of the line parallel to line A and passes through the point 3, 4. Well, that's in general form. We want it in gradient intercept form. That's going to help us find the gradient, and it's much easier for us to work with. So x plus 2y take 1 is equal to 0. So that means that 2y is equal to negative x plus 1. Now I just need to divide everything by 2, because dividing everything by 2 is going to get me my gradient intercept form. Negative x plus 1 over 2. Now from this, I can tell that my gradient is equal to negative 1/2. So my gradient is negative 1/2. So therefore, my line has equation negative 1/2 x plus c. We know it passes to the point 3, 4, so let's just put in those points. 4 is equal to negative 1/2 times 3 plus c. That's going to get me to 4 equals negative 3 over 2 plus c. So 11 over 2 equals c. I've changed 4 to 8 over 2 because I need to write it as a fraction over 2. So 11 over 2 is how I get that, by adding 8 and 3 together. So the equation of my final line is going to be that y equals negative 1/2 x plus 11 over 2. Or you could write it as one fraction, so negative x plus 11 over 2. Both answers are really the same. It just depends on if you want to write it as a fraction or not as one whole fraction. Find the equation of the line that is perpendicular to A and passes to the point 3, negative 4. Well, we know the gradient is equal to negative 1/2. We just figured that out from the question above, right there. Well, if two gradients are perpendicular, then they should multiply to give me negative 1. So m1 times m2 should equal negative 1 if the lines are perpendicular. That means that negative 1/2 times m equals negative 1. Well, by dividing both sides by negative 1/2, m2 is just equal to the gradient of 2. And that's super helpful because that's a nice number to work with. So y is now equal to 2x plus c. Now again, I plug in the points 3, 4 into my equation. So 4 is equal to 2 times 3 plus c. 2 times 3 gets me 6. So 4 equals 6 plus c. So negative 2 is equal to c. Therefore, y equals 2x take 2 is perpendicular to the line originally that we had, and it passes through the point 3, 4. So if the lines kx plus 4y equals 3 and the line k take 2x take 2y equals 7, if they're perpendicular, we need to try and find the values of k. Now, that word perpendicular, I don't know how to prove if anything's perpendicular unless their gradients multiply to give -1. That shows me a hint in that question. That word perpendicular in my question makes me think I should need to probably try and find the gradients of these lines so I can multiply them and test if they equal -1. First thing I need to do, however, is I need to rearrange them into gradient intercept form. So for my first line, kx plus 4y equals 3. Well, that's going to be 4y equals negative kx plus 3, and then I divide it all by 4. For my other line, it's basically the same thing. I'm just going to skip the step where I rewrite it, and I'm just going to go straight to rearranging it. So that's going to be negative 2y equals negative k take 2 x plus 7. So y is equal to, I'm dividing it all by the negative, so then I need to change the signs of those numbers. K take 2 x take 7 over 2. So now I can establish that my gradient for this first one is negative k over 4. The gradient for my second one is k take 2 over 2. Now, if two lines are perpendicular, then they need to multiply to get me to -1. So I need to try and multiply these two, and it should give me -1. That's going to help me find the value of k. So negative k over 4 times k take 2 over 2 is equal to -1. Well, let's figure it all out now. So negative k squared negative times a positive plus 2k over 8 equals -1. Well, that's negative k squared plus 2k equals -8. And now I'm going to move my k squared across, my 2k across, so 0 is equal to k squared take 2k take 2k take 8. Now it's time to factorize my normal trinomial. What are the factors of -8 that add to give -2? Well, that's going to be -4 and +2. -4 plus 2 is -2. They multiply together to give -8. That's an answer. K take 4, k plus 2. Okay. Now that I've done these, I know that either k is equal to 4 or k equals -2. They're the two values of k in which this solution is true. Okay, need to try and find the x and y intercepts of that function. Y-intercept's super easy. The y-intercept is just 0, 16. I know that because of the value of c at the end. All right, the x-intercepts, well, this is where I need to try and factorize it out and use the null factor law to find those values of x, because when y is equal to 0, that's when the graph has an x-intercept. So it's going to be that 0 is equal to negative x squared take 6x plus 16. I'm going to multiply everything by a negative because that's going to help me factorize, because we like dealing with positive numbers. Luckily, 0 times a negative is just still 0. So what are the factors of -16 that add to give 6? That's going to be that x plus 8 x take 2. Therefore, x is equal to negative 8 and positive 2. So my x-intercepts are going to be the 2 points, negative 8, 0, and 2, 0. The equation for the line of symmetry, well, the line of symmetry has equation x equals negative b over 2a. My b is negative 6, my a is negative 1. So that's going to be negative 6, so positive 6. 2 times negative 1, which is negative 2, so 3. Therefore, the line of symmetry has equation x equals negative 3. Alright, and I'll label these as well. Okay, finally, the coordinates and nature of the turning point. The turning point has to lie on the line of symmetry. We know that because it's the nature of a parabola. So, if it lies on the line of symmetry, we know x is equal to 3. We put that into our y equals negative x squared, take 6x plus 16. We get that point, we put it in. So y is equal to negative 3 squared. Take 6 times 3. Oh, sorry guys, it's negative 3. So that should be negative. That should be negative. That should be negative. Plus 16. So that equals negative 9 plus 18 plus 16, which equals 25. Therefore, the turning point is negative 3, 25. And now the question also asks for the nature of the turning point. Well, we need to try and figure out, is it a minimum or is it a maximum? The minimum value would be if x is a positive, x is not positive, the value in front of x is negative, so it is a maximum turning point. We know that because of the coefficient of x. We have that negative 1 here in front of the x, so it flips our parabola against the x-axis, which makes it a maximum turning point. Sketch the function x squared take 4x take 1. And I'm going to zoom out just so we have a bit of room to work with here. Okay. First things first, y-intercept is 0, negative 1. So I'm going to put that on there straight away. Okay. Where's the x-intercepts? Well, I can tell already that that's going to be difficult, so I'm going to start with the turning point and line of symmetry. So the line of symmetry is negative b over 2a, negative 4, that's going to give you 4, over 2, which equals 2. So my line of symmetry is going to be right there on that point, x is equal to 2. Now I'm going to put x equals to 2 into my function. So y equals 2 squared, take 4 times 2, take 1. And that's just going to be 4, take 8, take 1. So negative 5. So therefore, the turning point is 2, negative 5, which I can label here. So now you can probably have a rough idea of what the parabola is going to look like, but we don't know the roots of this equation, and looking at it now, I know I can't factorize it. What are the factors of negative 1 that add to give negative 4? You're not going to have one. This is where we need to use our quadratic formula. So for the x-intercepts, x equals negative b plus or minus the square root of b squared take 4ac over 2a. Now, I'm completely aware that we are trying to get you practicing for a non-calc test. However, the questions I chose, you can't do this without a calculator. So, do it with a calculator. Do these questions with a calculator, and it's going to get you that you've got 4 plus or minus the square root of 20 over 2. The decimal approximations of those answers is about 4.23 and negative 0.23. So you can put them in to about there, round about there as well. And now we have the points and can sketch the parabola. And that would be how you sketch that function. Again, another sketching one. We don't have it in our form that we want, so first we need to try and rearrange it so that we can like the form and we can deal with it in the way that we like to see fit. So I'm going to take away that x squared across, take away the 2 across, take away the 16x across. 2y is equal to negative 4x squared. Take 16x plus 2. Notice how I've swapped all the signs as I've gone across the equal sign. That's going to be important. So y is equal to negative 2x squared. Take 8x plus 1. Okay. Now from this I know my y-intercept. It's 0, 1. Y-intercepts in general form are always really easy to just pick out straight away. So that's why I always suggest you just do that. Alright, the line of symmetry equals negative b over 2a, which is negative 8. So it's going to be a positive 8 with that double negative over negative 4, because 2 times negative 2 is negative 4, which equals negative 2. So my line of symmetry is going to be negative 2. Again, just sketching that there. So I know that that's where my turning point is also going to lie. Now I'm just going to put that negative 2 into my function. Y equals negative 2 squared. Take 8 times negative 2 plus 1. Negative 2 times 4 is negative 8. Negative 8 times negative 2 is 16. Plus 1. So that's going to get me 9. So I know that my turning point is equal to the point negative 2, 9. All the way up here. Okay, and again, we're going to be dealing with the quadratic formula. And you're going to be getting roots. You can probably get the general idea of what the graph's going to look like because we're so good at parabolas by now. But we're going to be using the quadratic formula again. We're going to be using that x is equal to negative b plus or minus the square root of b squared take 4ac over 2a. And just because I feel like this video is long enough already, I'm just going to skip to the part where I give you the answer. And the two intercepts 0.121 and negative 4.121. So it's going to be about here and about there. Notice that they're always the same amount of distance away from the line of symmetry. Because parabolas are symmetric, they're always going to be around about the same distance. Well, no, they're always going to be exactly the same distance away from the line of symmetry because they're symmetrical. And that would be how you sketch that graph. Again, I know that doesn't look amazing. You know that doesn't look amazing, but that's exactly what we want. We want the working, we want the step-by-step methodology, and then that's going to show us how to get the answer. Lucky last, final question. A parabola has the equation y equals negative x squared plus bx plus c. Find the values of b and c such that it has a turning point at negative 1, 4 and a y-intercept at 0, 3. It's told us that the y-intercept is at 0, 3. So straight away, I can tell you that c is equal to 3 because of the y-intercept. So that means that I can write my equation as negative x squared plus bx plus 3. Well, I know that my turning point lies on the line of symmetry. So, the line of symmetry is negative 1, because it says it right here that that's where my turning point is. Negative b over 2a has to equal negative 1. Well, we know that a is equal to negative 1, so 2a is equal to negative 2. So negative b over negative 2 equals negative 1. Negative 2 times negative 1, by moving that across, so negative b is equal to 2, b is equal to negative 2. And you put that into there, so you know that b equals negative 2, c equals 3. And they're your answers. Hopefully this video helps you guys study for your test. Make sure we are revising and going over these solutions. This test really should have been done without a calculator, okay? The only questions it is required is the sketching graph questions because of the quadratic formula. I should have picked nicer numbers, but I didn't pick nice numbers, so I'm sorry for that. But otherwise, this test is absolutely capable without a calculator, and you need to get in the habit of that non-calculator because you're not going to have one in this first test.